And without further ado, let's move on to our first presenter, who is an experienced solution architect who works on state-of-the-art software engineering products. He has a background of 15 plus years in agile software development in the roles of developer, team leader, and mentor. He has comprehensive knowledge of current architecture design and software engineering approaches, while his focus areas include cloud, web, microservices, Java, API management, event streaming, and analytics. The title of his talk, A Practical Tale of Assessing a Microservices Architecture. Please welcome on stage with a huge round of applause our first speaker, Tamás Gelesz.
Thank you. Thank you. Good morning. So my name is Tamás Gelesz, and I will be talking about a case study of a microservices architecture assessment I did recently. So I work as a solution architect at EPAM. I usually do architecture design, but occasionally I also do architecture review, and I work on a variety of projects and customers. This is quite usual at EPAM because we are exposed to a lot of clients, so we're not stuck in the same project, we never get bored. I focus on various technologies, mostly cloud, web, and microservices, occasionally API management, event streaming, and analytics. I used to be a Java developer, and I live here in Budapest. So this is how I would like to structure my presentation. First, I'd like to set the context and define the goals of this engagement. Then I would like to get into the details of the structural assessment of the microservices architecture. Then there will be a part about looking at other quality aspects. And then I would like to summarize the takeaways of this presentation and have some time for questions. So let's define the context and goals of this engagement. So in a nutshell, this is a large client. I can't really share more about it, but this is quite a big company. And they built a microservices framework without prior experience with microservices, and they wanted somebody to assess this architecture. And in terms of what this does, it's fairly simple if you look at it from a high level. They have a lot of UIs, and their UIs have a lot of text, a lot of labels on those UIs. But this is not specific to any industry. And they built a framework, they built a system that customizes the text on the UI to specific industries. If you look at the example on the slide, in the standard system it would be factory. If we customize that to healthcare, that would be hospital. In education, that would be school. Similarly, if the standard term is client, then that would be, let's say, patient in the healthcare industry, and in education it would be student. So this is what this system does on a high level. Okay, so this is how the task looked like. They basically said that they want to understand the quality of their architecture. What was done well, badly, are there any low-hanging fruit, any suggestions on best practices, making it more stable and adding resiliency to it. And they wanted me to come up with recommendations, some cost-benefit assessment, and some prioritization of the to-dos. Their approach was quite free, I would say, so it gave me a lot of freedom. They dedicated people who could help me from the customer side. They offered access to a lot of things, documentation, source code, all kinds of systems. But they wanted me as the assessor to drive what I delivered. So there was a lot of freedom here. And this engagement lasted for a couple of weeks. So I needed to come up with a strategy on how I approach this, if this is so free. And I decided to define the following things as a first step. So, number one, what is the strategic importance of this assessment? Why are they doing this at all? Why are they funding this assessment? And the answer here was that it was driven by the engineers, and they had a budget for the quality assurance. Number two was, what is the scope of the assessment? Who will actually read this assessment? Again, this was about solution architecture only. They actually mentioned reviewing the development processes at one point, but it turned out that it was only about solution architecture. And this was for the engineers mostly. Number 3 is about what are the business drivers, what are the product goals, what stage the product is in. They gave me a lot of documents which defined a lot of things, but not everything. So things weren't sufficiently defined. And the product was mostly developed, but not in production yet. Number 4 was what architecture design they had and what decisions they made. And the design process was quite heavy, big documents, but they didn't cover everything that I thought would be important for such a design. And it was difficult to understand everything from the documents only. And lastly, what systems are involved? Well, they gave me access to the system, documentation, source code, build pipelines, mostly everything. So this is the initial view I put together of the system. So this is quite high level, but it summarizes the context well, I think. On the left side, you can see that there are multiple source systems which have text, standard text, which are not industry specific. And this text customization system does the following. It imports the text. There is a rule-based transformation. There is some manual review and manual correction done. Then we get the customized text for the industries. And all of this is fed back to the source systems. And also there is a query interface where you can query the standard text, so the original text and the customized text. This was done with a dozen microservices, several web UIs, and the methodology that they used was quite up to date. They used domain-driven design, event storming in some cases, but they said that each of the backend components had its own bounded context, which I didn't know where to put at this point. They used messaging to integrate the backend components with choreography, so everything was reacting, nobody was orchestrating the others, but all of the services persisted all of their inputs and outputs. So on the bottom side, you can see some of the questions that I started to have. So the design and approach is quite up to date, but does it really fit the use case? Did they overdo domain-driven design? What are the non-functional requirements? What are the quality attributes? What is the quantity of data that we are looking at? And what are the query use cases? And these were not to be found in the documents that they gave me. This is why I said that it was insufficient. So I started writing my initial thoughts. On the right side in yellow, you can see the structure of the document that I started to create. It gave some initial context, then it looked at the architecture from various aspects, mostly quality attributes. And the first things I collected the first topic was business alignment. I said that quality attributes are not clearly defined, and the query use case is also not defined well. The documentation is fragmented, and it's partially outdated. So there were documents here, there was GitHub there, some of it was up to date, some of it was already outdated. And from the documents, you don't get to understand what this system does. I collected issues and added 2 labels to them. One was severity of the issue, from red to blue. I mean, red would mean that the product will fail. Blue was something very much less severe. And also some estimates regarding the efforts. So let's get into the details of the structural assessment of the microservices. So you have seen a top-down view in the previous slide. Now let me show you a bottom-up view of this. Here you can see that I collected statistics using source code analysis. In the yellow box, you might see, you might not see, but it's a collection of simple shell commands, how I collected these statistics. Everything is anonymized due to privacy reasons, but I think you can see the main message here. So there are a dozen components. There is also a shared library in the first line. You can see the lines of code, And this customer was talking about a microservices architecture, but you can see that there are services which had like almost 20,000 lines of code. So this got me thinking, are the components too big? I saw that there was a shared library, and I saw that each component, well, most of the components consumed messages from the event bus, had several entities, exposed REST endpoints. I was thinking that maybe the components have too many responsibilities. And what about the shared library? Is this a good thing or a bad thing? So these were my initial thoughts, but I continued the investigation. This is a view of how components are connected with various message types. So the legend is on the top left side. The boxes are components, the ellipses are certain message types. The blue arrow means that a message is created, published by a component. The black means that it is consumed. And this is the actual graph, but without labels. And you can see that if you look at one box and another box, there are several parallel message flows. And I was thinking, why are there so many messages between the same components? Is the level of granularity too low? A lot of components are talking with a lot of other components. Again, are there issues with responsibilities and coupling? And also you can see some messages that either have only a consumer or only a publisher. I was thinking, does this mean that there is dead code, or maybe there is some mistake in the analysis? I mean, if something is consumed, something is published, it should be consumed. This is another look at the previous diagram, but in an Excel format. In the rows, you can see the message types. There were like 65 messages, so this is just a partial view of that table. You can see in the third column that they defined an async API contract, which is similar to OpenAPI, but for messages. And you can see which component publishes the messages and who consumes these messages. And here I saw cases where nobody consumed the message, which was strange, and I saw cases where one message was consumed by a lot of components. I was again thinking, is this done correctly? Why is this like this? And why are there so many messages? And why are there messages that are not defined in the open async API contract? And why are there messages that nobody uses? So I looked at the database as well. This is a view about the entities in the rows and which components has that entity. Now you can say that if a component has an entity named something, the entity in the other component named the same way might be different, because everything has its own bounded context here. But again, this is an indication of reusing the same data. Why are there so many? While in a few cases, why are these components using the same data again and again? Are there issues with responsibilities? And why does each backend component have its bounded context? So based on this analysis, I collected a set of initial findings, like potential issues, and I discussed these with the engineers. I talked about component size, responsibilities, boundaries, type coupling, level of abstraction, and why are there so many bounded contexts. And the customer said that, well, you know, we decided like this. We have our reasons behind this. And we talked about pros and cons, but it seemed that the issues or the findings are interlinked. So I didn't have any concrete solution that you should change this, because that would have an effect on other aspects. So my idea was the following. Let me collect the drivers of the architecture and create a reference design for them. I would compare that architecture with what they have, and we can look at differences, or we can look at the similar things, and that would affirm their architectural decisions. So I collected quality attributes, the most important non-functional requirement, and I decided to go with domain-driven design. So let me briefly talk about DDD. This is going to be very brief. There are very good resources out there, and this points to some of these. There is a great article by Microsoft which basically defines a 4-step process to defining microservices boundaries. So first you analyze the domain, the whole thing, then you split it up into subdomains. A bounded context is a model for each subdomain, and then you do more design in each bounded context. You define things like entities, aggregates, and services. I will talk about this in the next slides. And based on this tactical DDD, you identify microservice boundaries. There are great resources. That book on the right side is excellent, and also if you have access to LinkedIn Learning, I also recommend that. So this is the first step of the reference design I did. This details bounded context that I identified. On the left side you can see two source systems. One of the systems, I named it XYZ for the presentation, but it's obviously called something else. So there is a source system where you can extract the standard terms from. This is like an object storage kind of thing. It's native to the corporation that I did this assessment for. And you also had on the bottom side source code where you could pull standard terms from. In the middle, I defined a bounded context or a subdomain called language customization, and I assumed that there would be clients or downstreams to this, and that's what you see on the right side. And if you look at DDD, you can say, okay, you need to do DDD with domain experts. That's an obvious limitation here because I didn't have access to domain experts because this assessment was done in a few days. But you can see that in my design, I was talking about a single bounded context and not a bounded context for each backend component. What I haven't mentioned before is that besides the language customization, this department worked with translating text as well. So not only customizing text from the standard text to a specific industry, but also translating it from one language to the other one. And I had a dilemma. Is this in the same bounded context or is it a different bounded context? I didn't have a definite answer to this, but even if I said that this would be a different bounded context, I was talking about 2 bounded contexts and not 12. So you see this, you saw the cylinder or the ellipses in the middle. This is the second step of domain-driven design where I design the details. The diagram on the right side is not really important, and I don't think you see the details. It's more about the structure. So here in the tactical DDD, I designed entities, aggregates, and services. So what are these? Entity in terms of DDD is something that you persist in the database which has an identifier. An aggregate is a collection of entities which defines a consistency boundary or a transactional boundary. This is an important thing when you do microservices because you don't want to split aggregates into multiple microservices because you will need to manage distributed transactions or sagas, and that's going to be complicated. So you need to understand what the consistency boundaries are. And services are basically logic that is specific to the domain. You can see the legend on the left side, on the top left side, and this is the design for this bounded context. On a very high level, it ingests data, it transforms it, it provides some UIs and the query interface, and then it feeds it back. So we will use these in the next slide. So here we are in the last phase of microservices design, where we take the inputs from the previous diagram and we assign each of these to a microservice. So we're defining microservice boundaries. The rule of thumb here is that a service shouldn't be larger than a bounded context, but it shouldn't be smaller than an aggregate, as I mentioned previously. And domain services can be microservices as well. You need to consider a lot of other things like team size, other non-functional requirements, security, release processes. So there are a lot of things when you define microservice boundaries, but you need to respect these rules. And what you see in the table is, in the first column, it's a list of all of the aggregates and domain services from the previous diagram. In the middle column, you see how I assigned those two components. So you see a mapping from those to the components I defined in the reference architecture. And on the right side, you see that how the customer did it originally. And you can see that there are mismatches. So the level of granularity is not the same in the reference architecture as in the original architecture. So this was something that I discussed with the customer. And they said, similarly to the previous discussion, that, okay, they understand my points, but they felt that something was missing. So I thought, okay, maybe some inputs are missing to the architecture design. So we had another round of deep discussions, and through these discussions, I discovered a couple of things that were important. So number one, data quantity is larger than what was anticipated. They didn't give me an exact figure in the original discussions, but I insisted them to give me an estimate, and it turned out that the texts can be in the range of hundreds of gigabytes. And this was interesting because I didn't really consider this. So this was an architecturally significant requirement that was defined at this point. They didn't know it either. Number two was that they have a quite heavy process on creating new components. Testing, validation, security, etc., etc. So this is a driver to them not to make a lot of services, but to combine them into compound services. And number three was something that they didn't know about, but it was, let's say, logical from analyzing the business drivers behind this product. And this was that in the future, the standard texts, which are agnostic to the industry, and the industry-specific terms will need to be combined in queries. And if you look at the data quantity, then this implies that these two pieces of data should be stored together in the same database. So these were the three important things that were discovered during these discussions, and I redid the reference design task. And you can see the outcome on the right side. Well, you might not see the details, but you see that it's less granular. There are less components, and there are bigger pieces of code coupled together in components. And one important thing to mention here is that if you don't know the quality attributes and you don't know the business goals and drivers, you're in risk of designing a wrong architecture. And this is what happened to me in the reference design in the first phase. So let me summarize the conclusions of this structural analysis. The components in the revised reference architecture, most of them actually had a one-to-one mapping to the design provided by the customer. But there were differences in responsibilities. This approach that I detailed helped me uncover quality attributes, NFRs, for the customers and business goals, which they didn't know about. And we had the opportunity to define architecturally significant requirements and drivers. And this sort of challenging of the architecture through redesign of a reference architecture actually can help you, because if you find something that is different, then you can talk about it. And if you find something that is the same, it validates the architectural decisions that they made, or maybe implicitly made. But still, I collected several issues which are listed on the right side. So standard and customized texts are not owned by the same component, which will probably be an issue considering the data quantity and the query requirements. Number two was that the components are tightly coupled with the specifics of the source data systems. And number three was that they had, as I mentioned, some rules on how to semi-automatedly transform text to industry-specific text, but this was also coupled to the way they represented search terms and replacement terms. And I was saying that you need to decouple this because probably you will want to introduce machine learning in the near future. Okay, so this was the deep dive into the structural assessment. Let me talk about some other aspects of this architecture. So I looked at additional quality attributes, and these are the following. And these were also quite important. Until now, we have been only focusing on this microservices assessment because this is what they actually asked for, but I wanted to give them the whole picture of how I see their architecture. I was thinking that they may have done microservices well, but does the system actually fit this purpose? And the first aspect was about performance and scalability. And it was very interesting to discover that they hadn't finished load testing. So they don't know the limits of their own system. And I identified this as a risk. I mentioned previously that they were storing all of the messages in the databases for each component in the backend. And I was telling them that, well, this might be a bottleneck later in the phase. The message bus can persist the messages for you for some time as well. Number two was about consistency. They had issues, so they wanted to follow the pattern of at least once delivery, but the processing wasn't idempotent. I was saying that you might have consistency issues here. I mentioned that they used rules for processing, for transforming standard terms to custom industry-specific terms, but they didn't version these rules. And they had some processes for manual data correction, but this wasn't robust enough. Number three was about maintainability. They didn't have distributed tracing, but they were working with the microservices system. And they weren't collecting all of the meaningful metrics. I suggested for them to use the 4 golden signals, which was published by Google. The next item was about availability and reliability. They had a known issue with the message broker. They said that in certain cases the message broker might overload. There were issues with memory and disk thresholds, and they were only running this system in a single region. The next item was about extensibility and deployability. I think it was a good practice to use async API to define their messages in the forms of contracts, but they didn't version this. And they didn't use code generation for async API. And I mentioned a point about having a shared library in the microservices. Well, some people say that you shouldn't share anything with microservices, but some people are, I think, more pragmatic, and they say you should share as little as possible and you need to keep the single responsibility. I am more favoring the second approach. But in this case, I just issued a warning for them that you need to keep an eye on your shared library because you might be assigning too many responsibilities to it. You're not naming it correctly. It's called common shared or something like that. And the last item is about usability. They had several UIs which looked like a portal, but it didn't really behave one. So here again, I would like to refer you to some good resources that you can find on the topic. The link below by O'Reilly, Microservices, Anti-Patterns and Pitfalls. I think that's a great read. And I can also recommend you to view the course on 12-factor applications and also the book on the right side. So I summarized what I recommend them to do in the form of an action plan. There were dozens of issues I collected, but I also gave them a roadmap to what I see would be the best. And I categorized them into several groups. So number one is to get the architectural significance right. This is number one. You need to understand the quality attributes. You need to define the query use cases. If you're not doing this, your architecture might be wrong, simply put. Number two was about getting the baseline, the existing system, to a level that is reliable. Finish performance testing, identify the limits of the system, address the issue with the message broker, and add distributed tracing if you find performance issues or issues with performance. Number three is looking at the future, so making the system future-proof. This is the point where you need to reconsider component responsibilities. So let's do that, and after that, look at the potential bottlenecks, if they still exist, and then do all of the tasks that would make the system reliable and consistent, so ready for production. And then go to production, obviously. And number four was about efficiency and delivery efficiency. I was suggesting to them that you need to do frequent production releases, and you need to address a set of items that I identified, which is in relation to efficiency. And in parallel with all of these, I was suggesting to them that reform the way you document things. Have live documentations. Define what sort of documents you are keeping alive and what sort of documentation you say that it would be obsolete. So you have a current view of your system, but you don't need to necessarily update your previous solution architecture designs. So this was the whole presentation. I would like to summarize the takeaways from this talk. So number one, I think it's essential to understand the goal of the engagement, the scope of it, and how it benefits the sponsor. So somebody is paying for this, and you need to know why this is beneficial for them and for all of the stakeholders.
All right, thank you. Okay. Have you considered organization, how teams are organized in the proposed architecture?
Yes, yes. In this specific case, they had, let's say, each of the components had a team that owned it. I think they had like 3 teams and 12 services, so each team owned multiple services. This is definitely an aspect that you need to consider when you create microservice boundaries, that it should be owned by a single team. Mm-hmm. Even better if a subdomain, is owned by a single team, and all of the microservices in that subdomain are owned by the same team. That's also something that helps you be more effective.
All right. Coming up next, is scalability the main factor for dividing microservices, or can there be some more important aspects? How do you find which aspect is the most important?
Scalability is an important aspect, but so in a microservices architecture, you can have additional benefits. You don't need to use the same technology stack for all of the services. So you can utilize more the different teams. You can, if a single component is smaller than a monolith, then the individual developer can ramp up faster. So it's more effective in terms of delivery. Also, you might want to limit how much visibility an individual has on the system. I mean, I'm talking about security, for example.
Okay, thank you. Is it realistic to redesign, adjust the architecture when the solution is already fully implemented? How source consuming is that?
It depends, which is an answer to a lot of questions. So
the Jolly Joker answers, right?
So in this case, this was before production release, and I identified several issues for the production release. I think those had to be considered. All of the other things regarding delivery efficiency, it depends on what the customer wants to achieve and their budgeting.
All right. Last but not least, as
Okay.
of now at least, do you know whether the customer finally changed anything based on the suggestions? If yes, what?
No, the last point of this engagement was me giving them this document, and they said it was very insightful, but I didn't get any response on what they actually did.
Okay, apparently it wasn't the last question because we have another one coming up. Does DDD make sense in a startup where many uncertainties exist and the bounded context can change anytime and will most likely change?
I think if you understand the principles, it's good input to your architecture design, but I'm not suggesting doing full-blown DDD. Like here, I didn't do it either.
All right. Thank you very much.
Thank you very
with
much.
that we got to the last question. Thank you, dear audience, for the amazing
Thank you very
questions.
much.
It made it a lot more exciting for me as well. And a round of applause to Tamás.
Thank you very much. Thank you. Thank you. Thank you.